Hello there, and then welcome to Hub Beyond Numbers, where we learn math the easy way. We are still on probability. Now, in this video, we are looking at independent events. Independent events, and we want to understand what independents are. By the end of it, you'll be able to identify independent and independent events and use the multiplication rule for independent events to solve problems involving them as well. So without much ado, let's quickly go into it. Now, what do we say is an independent event? So two events are said to be independent if the outcome of one does not affect the outcome of the other. So this is what we have on the screen here. It says two events are said to be independent if the outcome of one does not affect the other. What do we mean by that? So let's say you are playing Ludo, the game of Ludo with someone. The fact that you have gotten 6 does not mean the person cannot get the 6. You get it? So your outcome does not affect the other person's outcome. In simple terms, that is what we mean, right, by independent events. So both events are independent, they are on their own, and then they can get any probability value irrespective of what the other one gets, right? So we'll be applying this idea to solve some of these questions. With that in mind, let's look at what the multiplication rule for independent event is. So here we have it. The multiplication rule says that if you have two events, so let's say event A, this is our event A, and then event B, this over here, and you want the probability of event A and B occurring, then it is the product of the individual probabilities, right? What do I mean by that? That is the probability of A multiplied by the probability of B, and that is the multiplication what rule. Probability of A and B is given as what? Probability of A times the probability of B. So that is the independent event, and then this here is the multiplication rule. So let's look at how we can apply these in questions. So looking at our first example here, it says a coin is tossed, right? And a die is rolled. You have to find the probability of getting a head and a 6. A head and a 6. That is number one. And then the second one is a tail and then an even number. I didn't go through the steps of looking for the probabilities of this individual or this independent events. I'll just go straight to the point because we have already treated these in what the previous video. So let's quickly go into it. So our solution, we first of all need to know the probability of getting a head, right? So you say probability of getting a head is equal to what? Talking of head, we know the sample space of a coin is what? Head and tail, right? And how many heads do we have there? Just one. So that is 1 over 2. And then the probability of getting a 6, the sample space of a coin experiment, a die experiment is what? 6. And how many 6 do we have there? Just one, right? So now, solving for the first one, the probability of getting a head and a tail, and then a 6 is going to be, we said, is the using the multiplication rule, right? So it's going to be the probability of what? A head times the probability of a 6. And we know the probability of a head is what? 1 over 2. So times 1 over 6, which is the probability of getting a 6. And multiplying that, we have what? A 1 all over 12. So this simply implies that the probability of getting a head and a 6, as the question has been asked us, right, is what? A 1 over 12. And that is just it. You see? So just understand the fact that if you have two independent events and you want the probability of both of them occurring, that is, and the first one and the second one, then we are using the multiplication multiplication rule, which says that we should do what? We should just find the product of the two, what do you call it, probabilities. Now let's look at the second one. It says find the probability of getting a tail and an even number. So going straight to the point, we start by saying what? The probability of getting a tail, just like the previous one. So probability of getting a tail is also 1 over 2, right? Then we said the probability of getting an even number. Remember the sample space of a die: 1, 2, 3, 4, 5, and then what? 6. And how many even numbers do you have there? 2, 4, and then 6. There are 3. So the probability of getting an even is going to be what? 3 all over the number of elements in this sample space, which is what? 6. You see? Okay. Which can also be written as 1 over 2. But our question is a tail and an even number. So we say the probability of getting a tail and an even number is going to be the probability of getting a tail times the probability of getting an even number. And we know the probability of getting a tail was 1 over 2. So times the probability of getting an even number, which is also what? 1 over 2. And multiplying that gives us what? A 1 over 4. Straightforward, right? So simply put, if we want to use the multiplication rule, right, to get the probability of what? Independent events, just look at the two events you are considering, event A and then event B, all right? And you just multiply them together, and that is it. So let's solve one last example, after which I give some for exercise. So let's look into this question. It says a bag is what? A bag contains 5 blue and then 3 red balls. A ball is picked and then replaced, and another ball is picked. Now to find the probability of 1 picking 2 red balls, and then 2 picking what? A red followed by a blue, right? So let's quickly look at our solution. Now, before we solve these probabilities of these independent events, then we need the probabilities of what? The individual events. You see? So looking at this now, we see it simply means that our sample space is made up of what? 5 blue balls and then 3 red balls, right? And that simply means the number of elements we have in our sample space is what? 8. So we have 8 balls. Now, if we have 8 balls, then the probability of picking a red ball is going to be what? 3 over what? 8. That is the number of red balls over the total number of balls. So 3 over 8. And in the same way, we can say that the probability of picking a blue ball is also going to be what? How many blue balls do we have? A 5. So 5 over what? 8. You see? Then we now come to the question. The A part of the question says the probability of picking a red ball and it says yes, picking 2 red balls. So picking 2 red balls, it means we are picking a red ball and another red ball. You see? And we said for these two independent events, if you want their probabilities, then we are just going to look for their product. So that is what? A 3 over 8, which is the probability of picking a red ball, times 3 over 8, right? And that should give us a 9 over 64. 339 and 88 is what? 64. As simple as that, right? Then that takes us to the next one, which is the probability of picking a red ball followed by a blue ball. So B, probability of picking a red ball, so red and a blue, right? The probability of picking a red ball is actually 3 over 8, as we have done here. then followed by a blue box with times 5/8. And simplifying that gives us a 15/64. So basically, this is how we work with independent events, right? This is how we work independent events. I'll put out some exercises you can try on your own just to test your understanding. So here you have some questions you can try on your own just to test your understanding. It's been nice having you. And in our next video, we'll be looking at the probability tree diagram. So see you in the next video and stay safe.